Hello. So now in this video we are going to look on into the deadlock avoidance algorithm called as the banker's algorithm. So in the previous video we have seen about the introduction to the deadlock avoidance and prevention and how we are going to determine whether it is in safe state or unsafe state. And today we are going to look on into this video with an example and the algorithm how it determines the state isn't safe or unsafe. So let's go into the algorithm part and we'll discuss with an example. So basically before the banker's algorithm is to be implemented, the resource allocation graph scheme always supports to identify whether the given state is safe or not. So here in this example, you can see the dotted arrow indicates it's a claim and the solid arrow indicates it is an allocated and request. And here in this example, the process P2 is requesting for the R1 which was held by the process P1. And currently the situation occurs as now P1 is requesting for the R2 and where P2 is also requesting for R2. So this is not going to be an unsafe because both are competing for a common resource which may be allocated for any one of the process. But in the second scenario, second diagram, if we see the process P1 holds the resource R1 which is requested by P2, and again P2 has occupied the resource R2 which is now requested by P1. So that obviously leads to a circular wait and it leads to deadlock which is termed to be unsafe state. So now using the banker's algorithm we'll determine how the safe and unsafe state has been determined. So in banker's algorithm there are certain things which we are going to assume it as. First one, we have multiple instances of a resource, each resource, and every process must claim for a maximum usage of resources. If they need 3 resources, they can claim for 4 or 5. So the maximum number of resources should be claimed in prior. And if a particular process requests for resource, it has to wait because it may be occupied by some other resources. When a process get all its resources, it must return back the resources after a quite amount of time where it is completed. With these assumptions, now we are going to compute 4 main matrices. First one, let's assume there are n number of processes to be termed as n and the resource as m. And we are computing with the available. Available means how many instances of the resources are currently available. Max indicates a matrix which gives you how much of the resources are requested by a particular process. Allocation, that also indicates by a matrix which indicates how many of the resources are being allocated to a particular process. Then need computes as what is the exact request or exact need of a particular process, which may be computed from the formula maximum minus allocation, because the need is going to change dynamically after every allocation. So the need has to be computed with the formula max of ij minus allocation of ij. And this is a safety algorithm which is followed for the banker's algorithm. First, we have to assume that the available should be taken as a work, and finish of I, that means I always indicates the number of processes, isn't it? So sorry, yes, finish of I is equal to false for every process. For example, I have 3 processes P1, P2, P3. I am assuming P1 doesn't complete it, P2 also doesn't complete it, P3 also doesn't complete it. That means finish of P1 equal to false, finish of P2 equal to false, finish of P3 equal to false. When this will become true is when the resources are allocated to the process and it has completed all its job, then that particular finish of I will turn to true. Second, for every process, now initially it will be taken as false or finish. Then we have to assure that the need must be less than the work. That is, need should be less than the available resources. If the need is not less than, then we have to wait. Then second one, when the need is less than and if the available can be allocated to that process, Now after allocation, the work has to be updated with the formula work is equal to work plus allocation. After which, when the total requested resources are allocated and the work has been completed, now that finish of I can be turned to true. Then again we are going for the next process. So this process is keep on repeatedly doing with an iteration till all the process pi has been successfully completed. If all completes and becomes the finish of I equal to true, that means the system is in safe state. If on particular instant the finish of I cannot be lead to true, then it means it is still in the unsafe state.